आज की क्लास में हम लोग प्रैक्टिकल से रिलेटेड डिफरेंट पॉइंट्स स्टडी करेंगे. वी विल स्टडी द टेस्ट ऑफ गैस, its related observations. Similarly, in the subsequent topics, we will study the taste of anions, and the taste of cations has been given in our analytical chemistry topic. So, in practical, when you have to write some observation, you have to identify the gas produced. Sometimes on the basis of the observation given, you have to identify the gas which is evolved, or you have to identify the anion or cation present in the given salt. Sometimes in the question, even in theoretical paper, it is given that identify the salt on the basis of given observation. At that time, you will be given two part of observation. The one observation based on practical will give you identification of the cation, and the other part will give you the identification of anion. Now, after identifying the cation and anion, you will find out the salt to be tested, salt to be studied. So, our today's topic is related to practical or related to observation. So, start with the practical and observations. It is important part because when in some questions, that is, suppose you have to derive observation, question is asked in ICSE, what do you observe when this is reacted with this? Then the observation is written on the basis of the products formed. It may be the evolution of gas, so you will write its observation, which type of gas is evolved, as well as on the basis of the different types of precipitate or the other points, you will identify the anion or cation and write its observation. So, in first part of it, I am going to start with the identification of gas. So, our first part is identification and observation of gas. Sixth gas, that is starting that chlorine gas. Chlorine Cl2. Now, how is the chlorine gas produced? When concentrated hydrochloric acid is heated with oxidizing agent like MnO2, PbO2, Pb3O4, K2Cr2O7, KMnO4, in that case chlorine gas is produced. So this is the simple method of producing chlorine gas, that is, when concentrated hydrochloric acid is heated with oxidizing agents. It may be MnO2, PbO2, Pb3O4 and so on. Then Cl2 is evolved. So this is the simple method to obtain chlorine gas in laboratory. Like you see, suppose we take this one as a reducing oxidizing agent. MnO2, this is black colored oxidizing agent, plus HCl. Now this is concentrated, on heating gives MnCl2 plus H2O plus Cl2 gas. Now this is balanced. So chlorine gas is evolved this time. We have to study the taste of chlorine gas, of the observation of chlorine gas. So what is its observation or characteristic? Wherever we are writing observation means we are writing its characteristic actually. So it is a greenish yellow. Now a student, you should learn its color. Greenish yellow acidic gas. Now you can easily identify chlorine gas with this color, greenish yellow colored acidic gas. There are only two colored gas which we have to study. One, this one, greenish yellow color. So this is directly identified. And second, nitrogen dioxide, which is reddish brown acidic gas. So with the color you can easily identify the gas. So a greenish yellow acidic gas having choking, pungent smell is evolved, which now chlorine gas can be identified by the one important test which turns moist starch iodide paper blue black. A starch iodide paper means the paper dipped in potassium iodide and coated with a starch is called a starch iodide paper. So when we introduce moist starch iodide paper in a jar of chlorine, then there will be change in color, that is blue black. This is the test for a starch. Like you see, what is it? Now this is potassium iodide solution. When it reacts with chlorine, it gives us KCl plus I2. Now this is colorless, but this iodine when gets added to a starch, then it turns blue black. So this is the test for chlorine gas. We can easily identify the gas as chlorine. The next gas is hydrogen chloride, HCl. Now hydrogen chloride gas can be produced by reacting hydrogen and chlorine directly. But in laboratory, when it has to be prepared, it has to be produced, then we produce it by the action of conc H2SO4 on chloride salts. Like suppose we have potassium chloride or sodium chloride. When concentrated, you must remember here concentrated sulfuric acid will be used, which is a less volatile in nature, means having higher boiling point. As a result, when it is heated at a temperature less than 200 degrees Celsius, actually the temperature is kept regulated because at higher temperature the reaction will not be favoring us. Like you see, in this case it gives this type of salt plus HCl. Now the HCl gas is evolved. how is the gas identified? So, if we'll write its observation, now we'll have many tests related to it. First, it is colorless, a colorless. Acidic gas. Now, wherever we write acidic gas means it turns moist blue litmus paper red. That is, the test for acid or indicators can be used. Acidic gas having choking smell is produced. Now it will be having the different tastes, which now there may be some tests related to it. First, produces dense white fumes. Dense white fumes when a glass rod dipped in ammonia solution. Ammonia solution means NH4OH. NH4OH is brought near it. Now, this is the first test, commonly used test. That is when a glass rod is dipped in ammonium hydroxide solution and brought at the mouth of the gas jar HCl or introduced in a gas jar of HCl, then dense white fumes is produced. And what is the compound present in it? Actually, it is HCl plus ammonia gives NH4Cl. So this is producing dense white fumes, that is ammonium chloride. So this is one test for it. Now go for the another test. When it is passed through silver nitrate solution. Then white precipitate is formed. This will be for AgCl, silver chloride will be the white precipitate, which is insoluble in nitric acid, but soluble in excess of NH4OH. Now, so just you see that when an acidic gas is introduced in a silver nitrate solution and white precipitate is formed, which is insoluble in nitric acid, means we will also add few drops of nitric acid for the test, but it will dissolve when excess of NH4OH is added to it. This will indicate the gas is hydrogen chloride. This test can also be used for the test of chloride ion or chloride radical, which we will study in the next topic, that is the test of anion. Now the reaction is HCl plus AgNO3 solution gives AgCl, this is the white precipitate, plus HNO3. Now white precipitate is formed, which is insoluble in nitric acid, but this white precipitate is soluble in excess of NH4OH. It gives silver diamine chloride plus H2O. Silver diamine chloride plus H2O. Now this is soluble. So this is the second test for hydrogen chloride or HCl gas. Now we have one more test for HCl, which will be again used for the test of chloride radical or ion. When it is passed through lead nitrate solution, then white precipitate is formed, which is insoluble in cold water but soluble in hot water. Actually, this is for lead chloride. This is the characteristic test of lead chloride. So, if any question, it is given that white precipitate is formed, which is soluble in hot water but insoluble in cold water, then it will be identified as PbCl2, lead chloride. So, you write here that is HCl gas, or in HCl acid also chloride radical tests will be obtained, is added to, passed through lead nitrate solution, then it gives PbCl2 plus HNO3. So this is the white precipitate. So students, we have studied 3 chemical tests for hydrogen chloride gas and their physical properties. Now, the next gas. The next gas is ammonia. Ammonia, NH3. Actually, this is the only basic gas which we have to study. So, it can be easily identified with the help of indicators, because there were many acidic gases like CO2, SO2, Cl2, HCl, NO2 and so on. But only one basic gas which we have to study, that is the ammonia. So if it is given that gas turns moist red litmus paper blue, it must be ammonia. How is it obtained in laboratory or for the test? By the action of alkali on ammonium salts. That is, when alkali is heated with ammonium salts. Actually, in this case, ammonium nitrate is not used because it will be explosive, except NH4NO3. Then ammonia gas is evolved. Like you see, suppose we take NH4Cl or NH4 whole 2SO4. Suppose it is heated with slaked lime. In laboratory preparation of ammonia, this reaction is preferred. Reason will be studied at that place. It gives salt plus water plus ammonia gas. Similarly, if we will add NaOH, it gives Na2SO4 plus H2O plus ammonia gas. Now, how is the gas identified? Observation. A colorless basic gas. Now, this should be remembered. Colorless basic gas means which turns moist red litmus paper blue. Basic gas having pungent choking smell. Now, pungent choking smell can be identified as the smell produced in urinals. In urinals, ammonia gas is produced by bacterial action on urea present in the urine. So that is the pungent choking smell, which now again we have two tests for it. One produces dense white fumes. Dense white fumes when a glass rod, it is similar to that of test for hydrogen chloride. Glass rod dipped in HCl is introduced in it or brought near it. The reason is that this time again that similar type of reaction takes place, that is dense white fumes appear. Here two gases react to form a white solid. So this is the test for HCl as well as for ammonia gas. And now the second test which helps us for the test of ammonia gas or for the test of ammonium NH4 plus ion radical, positive radical or salt, the positive radical in a salt without metal. So which turns Nessler's colorless Nessler's reagent, colorless Nessler's, it is based after the name of the scientists, colorless Nessler's reagent. And what is it? It is actually potassium mercuric iodide solution brown. So we have these two tests for ammonia gas. Now you have studied the many gases. Now the next gas, which is very simple to be identified. You can easily identify the gas, that is the ninth gas, nitrogen dioxide. Nitrogen dioxide or NO2. This gas is produced when nitrates of metals from calcium to copper are heated, calcium to silver are heated strongly. That is when nitrates of metals from calcium to silver, metal activity series, we use this one. When nitrates of metals from calcium to silver are heated, then this gas is produced. Like you see, that is, suppose we take lead nitrate. When in this range, that is, suppose we write this range like this, calcium to copper, take one range, calcium to copper. Suppose we take now lead nitrate. Actually in this range you will have the similar type of products like metal oxide plus NO2 plus O2. Now you see here, in this case NO2 gas, like a reddish brown. So just we have studied here, there are two colored gases which we have to study. One was the chlorine, greenish yellow, and second is reddish brown acidic gas, that is the nitrogen dioxide. Reddish brown acidic gas is produced. Now this is the simple test. You can identify it with its color only. So we have studied these several parts as the gases. Now the next part is 10th, water vapor. Actually, when a reaction takes place at high temperature and one of the product is water, then it may come out in the form of steam or water vapor. Or when some hydrated salt is heated strongly in a test tube, then on the cooler part of test tube, that is in the upper part, colorless neutral liquid droplets are condensed, that is water. So how is it tested? Suppose water vapor, suppose we test it by action of heat on hydrated salt. Hydrated salts. Now suppose we take Na2CO3.10H2O. This is the washing soda. When it is heated, it gives Na2CO3 plus 10H2O. This is the water of crystallization. So when heated, it will come out in the form of water vapor. Or suppose we write here CuSO4.5H2O gives CuSO4 plus 5H2O. That is, this is blue crystal and this is now white powder. White powder. So what do you see here? That is a colorless, neutral, liquid droplets condense on the cooler part of test tube, which now you see that for the water vapor there is two tests. One which turns anhydrous copper sulfate from white to blue. That is, anhydrous copper sulfate is this one, it is white powder, and when water is added to it, it again turns to blue crystal. Now you see, this is CuSO4.5H2O. Now this is the first test for it. Second, turns dry blue cobalt chloride paper. Now cobalt chloride paper is, when dry, it is blue to pink. That is, when water is added to it, it will turn pink. So if the blue cobalt chloride paper turns pink, then it will be water. This is a test for water. Now cobalt chloride, COCl2 plus 6H2O. It gives COCl2.6H2O. Now when it was dry, it was blue and now it turns pink. So this was the test for water vapor. So in any observation, in any reaction, if one of the product is water, now suppose a student, the reaction is taking place in solution, then you will not write observation for water. But when this type of reaction takes place, it comes out in the form of vapor and condenses separately, then we will write the observation for water vapor. Now take one more gas. Now this is nitric oxide. Nitric oxide, that is NO. Nitric oxide is obtained by reaction between nitrogen and oxygen, or catalytic oxidation of ammonia. Catalytic oxidation of ammonia. This is the reaction which we actually use in the laboratory. Like you see, ammonia and oxygen. We use the platinum catalyst at 800 degree Celsius temperature. It gives NO plus H2O. Now the question arises, how will it be identified? Then we see here that is actually this is a colorless, odorless, neutral gas, and neutral gas is evolved which turns, now from here you will have to observe its color, which turns to reddish brown acidic gas. Reddish brown acidic gas, that is NO2, when comes in contact with air, comes in contact with air. So this is the test for NO gas, means when it will come out, or as long as it will be present in the inside the flask, it will be colorless, but when it comes out in air, its color will change. So if the gas from the flask coming out changing its color, or outside the mouth of the gas jar, it will be NO gas, that is NO plus O2 gives NO2. So students, these were some of the gases. Now one more gas, although it is not asked generally, but we can have this gas, carbon monoxide. Actually this gas is obtained by insufficient combustion of carbon containing compounds or carbon allotropes of carbon. Now you can write it directly that it is a colorless, odorless, neutral gas which burns in air with pale blue flame producing CO2. Now another gas, and then you will describe the test for CO2 gas, that is turns lime water milky, but has no effect on acidified potassium dichromate solution. So students, we have studied all the gases given in our syllabus. It will be you will be able to study, identify, perform the practical, write the theoretical questions, and now it will be clear to you. In the next part, we will study about the test of anions. That is, in order to identify the salt, there are two parts. One is test of cation, another is test for anion. So we will study test of anion in the next part. Thank you.